Welcome to the DX Today podcast, where you get the fact without the hype.
It is great to be here.
Today is Wednesday, February 18th, 2026. And I want to start by, asking you to take a mental step back with me. Do you remember, it feels like forever ago, maybe 3 or 4 years back, when the absolute biggest deal in tech was asking a chatbot to write a haiku about, a dishwasher?
Vaguely, yeah. It feels like a completely different era, doesn't it? That was the generative text age. It was quaint, fun, but quaint.
It was. We were all just so blown away that the computer could talk, that it could be creative. But if you look at the landscape today, here in early 2026, that whole era is, well, it's effectively over.
It's table stakes now.
Exactly. We aren't asking the computer to talk anymore. We're asking it to work. We have, without a doubt, firmly entered the era of Agentic AI.
That is the defining shift. It's the biggest technological pivot of the last 18 months, easily. If you think about it, 2023 was all about the brain, the large language model, the reasoning engine.
Right, the intelligence.
But 2025 and now 2026, this has been about giving the brain hands. We gave it the ability to act, to do things in the real world.
And we were promised that those hands would do everything for us. This was supposed to be the year of set and forget computing. The marketing pitch was. It was incredible.
Oh, it was everywhere.
Don't just chat with your data, let your data run your business. That was the line. We were told these agents would handle our DevOps pipelines, they'd manage complex financial auditing, they'd reorganize our calendars, and even handle network administration.
All without us hovering over them. The dream of true autonomy.
The dream. And to be fair, for a little while, it seemed to be working. I mean, the efficiency metrics that companies were reporting were just, they were through the roof.
They were. Productivity was skyrocketing.
Until it wasn't. Until that whole dream just, it hit a brick wall. Or maybe a better way to put it is the perimeter shattered.
That's a good way to put it.
We are, of course, talking about the massive, industry-shaking news regarding OpenClaw. Just in the last few weeks, these critical vulnerabilities were discovered in what is, and this isn't an exaggeration, the fundamental plumbing of this entire agentic revolution.
That's right. CVE-2026-25253 and CVE-2026-25593. And I think it's important to be crystal clear right from the start. These are not your standard patch on Tuesday, forget about it by Wednesday kind of bugs. This is something else entirely.
When I first saw the report from iSecurity, my first thought was, okay, another bug, it happens. But then I started reading the technical details, the actual mechanics of the exploit, and honestly, my stomach just dropped. This isn't just a glitch in the code. It feels like a fundamental betrayal of the entire architecture we've spent the last 2 years building our businesses on.
It is a massive wake-up call. We got comfortable. We got, you could say, addicted to the convenience of this seamless, always-on connectivity between our systems and these agents. And now that same connectivity has backfired in the most spectacular way.
So that's our mission for today's deep dive. We are going to look past the headlines, past the scary CVE numbers. We aren't just going to recite the problem and move on. We need to unpack what agent hijacking really means.
Exactly.
We have to understand why this concept of brittle validation failed us so badly. And most importantly, we need to talk about why the entire industry is now scrambling to pivot toward what everyone is calling zero-trust AI.
It is going to be a technical ride, no doubt, but it's an absolutely necessary one if we want to move forward.
Absolutely. So let's start at the beginning. Section 1, the architecture of autonomy. We keep saying the name OpenClaw. For the listener who might be in management or maybe just follows tech a bit more casually, can you put into perspective just how big OpenClaw is? What is it?
I think the best analogy is this. Think of OpenClaw in 2026, the same way we all thought about Kubernetes back in, say, 2020.
Okay, so foundational.
Foundational is the perfect word. It is the absolute de facto standard. It became the operating system for agents. If you're a Fortune 500 company today, you are not building your own agent framework from scratch. It's too complex, too slow.
Yeah.
You are using OpenClaw. It's the scaffolding.
The scaffolding, I like that. So what is it scaffolding? What are the big use cases?
Well, it's everywhere. It's used in CI/CD pipelines to automate code testing and reviews. You push new code, and an OpenClaw agent is what picks it up, runs the security scans, and approves the merge request.
Okay.
Financial institutions use it for real-time transaction monitoring. It's the invisible layer that allows an AI model, that brain we talked about, to actually interact with servers, with databases, with third-party APIs. It gives the brain hands.
Okay, but let's draw a really sharp line here. How is that functionally different from the old chatbots? I mean, ChatGPT could write code and interact with plugins back in 2023. What makes an OpenClaw agent different?
The difference is the core concept of agency versus passivity. It's a huge distinction.
Passivity. You mean it just waits for you?
Exactly. The old chatbots were passive. They sat there and waited for a prompt. You typed a question, they processed it, gave you an answer, and then they essentially went back to sleep. They had no memory of the state of the world, and this is the crucial part, they couldn't initiate anything on their own.
Right, they were purely reactive. You had to kick them to get them to do something.
Precisely. OpenClaw agents are active. They are proactive. They operate on a continuous loop, always connected to what we call the control plane. The loop is simple but powerful. Instruction, execution, report. Then it does it again.
Walk me through that loop. Let's use an example. Say I'm a DevOps engineer at a big tech company. What is my OpenClaw agent doing for me?
Okay, perfect example. Let's say an alert fires at 3:00 a.m.
Okay.
A critical server is running out of memory. The agent, which is constantly monitoring the system, sees that alert. That's the instruction.
Got it.
It then decides, based on its programming and its understanding of the runbooks, to spin up a new instance to handle the load. That is the execution.
So it's actually doing something.
Oh, it's logging into your cloud provider, AWS, Azure, whatever, provisioning the server, rebalancing the traffic, all of it. And then it pings you on Slack or Teams to say, hey, I saw the memory alert on server 101. I've mitigated it by deploying a new instance, and system health is now stable. That is the report.
And it did all of that while I was fast asleep.
Exactly. It has a persistent, always-on connection to the network. It wasn't waiting for you to wake up and ask it to fix the server. It had the authority to fix it itself.
That word authority, that's doing a lot of heavy lifting in that sentence.
Yeah.
Because for an agent to spin up a server, or in the finance example, to move money, or to change a production database record, it needs keys.
It needs the keys to the kingdom. We're talking highly, highly elevated privileges.
Oh.
API keys with write access, sometimes root access to servers, production database credentials, access to PI, personally identifiable information. You simply cannot have an autonomous agent without giving it the power to act.
And this is where the architecture starts to get really tricky, right? The agent relies on the central hub, a gateway, to receive its tasks.
Yes. The gateway is its lifeline. It's the central server that's constantly feeding the agent its next job. Here's an alert to check. Here's a report to generate.
And here's where it gets really interesting. And by interesting, I mean, in retrospect, absolutely terrifying. The developers of OpenClaw, and almost everyone implementing it, made a massive, fundamental assumption.
A fatal assumption.
They assumed that because these connections, these conversations between agent and gateway were happening on internal configuration endpoints or over these special WebSocket connections behind the corporate firewall, they were in a trusted zone.
That was the fatal flaw. It's the old perimeter defense mentality, the castle and moat security model. The idea is that inside the house is safe, outside the house is dangerous. They just assumed that if a connection was established from inside the network, it had to be legitimate.
If you're already in the living room, you must be family.
Exactly that. And as we're about to see in excruciating detail, that assumption was catastrophically wrong.
Okay, let's get into the disaster. Section 2, the breach. This is the technical deep dive. The researchers at iSecurity are the ones who blew the whistle on all this. And they found two specific but related vulnerabilities. Let's start with the first one. CVE-2026-25253. They call it token exfiltration.
Token exfiltration. It sounds dry, I know, but it is utterly devastating in its impact.
So break it down for us. What is a token in this context? Let's get specific.
Think of the token as the agent's digital ID badge and keycard, all rolled into one. When the agent first connects to the gateway, it presents this token. The gateway looks at it and says, yes, you are Agent 007, you are authorized to be here, and here's a list of all the doors you're allowed to open.
So that token represents the agent's identity and its permissions.
Correct. The token is proof of who it is and what it's allowed to do. So if you can steal the token, you can steal its identity.
Okay, so how did the attackers steal it? What was the flaw?
The flaw lies in the WebSocket handshake.
WebSockets, we should probably explain that. That's the communication pipe, right? It's not like a normal web page.
Exactly. When you load a web page, that's a one-time request. Give me the page. A WebSocket is different. It's a persistent, open phone line between the agent and the server. It's the agent saying, hello, I'm here, I'm connected, just keep the line open and give me orders as they come in.
A persistent connection. Okay.
So when that connection starts, there's a process called a handshake. The agent says, I want to open a line, and the server says, okay, line open. The core vulnerability is that the OpenClaw framework failed to validate the origin of that handshake request.
The origin, what does that mean?
It's the who is asking part of the question. In web security, there's a standard piece of information sent with a request called an origin header. It tells the server where the request is coming from, which website or which IP address initiated this.
So it's like the caller ID for the internet.
Perfect analogy. It's the
Yeah.
caller ID. And OpenClaw, it just wasn't checking it.
Wait, so it saw the phone ringing and picked it up without looking to see who was
It
calling?
didn't even let the phone ring. It picked up.
That seems, it feels like security 101. Why would they miss something so basic?
It happens more than you'd think, especially with internal tools. The developers likely thought, this is only ever going to run on our own intranet. Why do I need to bother checking the origin? I know the origin. It's us. It's a shortcut taken for convenience that ends up becoming a superhighway for attackers.
So let's play this out. How does an attacker actually use this?
Yeah.
I'm the bad guy. I want that token. What do I do?
Okay, so you craft a malicious interaction. It could be anything the agent is programmed to ingest. Maybe you send a specially formatted ticket to the IT support system that the agent monitors. Or maybe you embed a malicious link in a log file that you know the agent will parse.
So I'm leaving a little breadcrumb for the agent to find.
Exactly. When the agent processes that input, the ticket, the log file, the exploit triggers it to open a WebSocket connection, just like it's supposed to.
Okay, so the agent opens the line. No harm yet.
But here's the critical trick. The malicious input you created forces the agent to connect to an attacker-controlled endpoint, not the real legitimate gateway, a fake one that the hacker has set up on their own server.
So the agent is told to call home, but the attacker has secretly changed the phone number for home in its address book.
Precisely. The agent knocks on the wrong door. And because OpenClaw was missing something called cross-site WebSocket hijacking protections-CSWS agent, for short, the agent doesn't just knock, it immediately tries to authenticate to prove it belongs there. It sends its token.
Oh no.
It literally hands its session token, its ID badge, to the complete stranger who opened the door because it was told this was headquarters.
I love that analogy you used earlier, the stranger knocking on the door. It's like a guy shows up at a secure government facility. He's not even wearing a good uniform, just a generic hat that says maintenance. He knocks on a back door. And the security guard inside the agent opens the door and immediately hands over his gun, his badge, and his keys and says, "Here you go, sir. I'm reporting for duty."
That is exactly it. It's not a failure of intelligence. It's a failure of protocol. The agent is programmed to be helpful. It's programmed to connect. It blindly followed the instruction to connect to the URL provided, and it blindly handed over its credentials upon connection.
And once the attacker has that token,
It's game over for that agent session. They have the token. They can now go to the real gateway, present the stolen token, and the gateway will say, "Welcome, Agent 007. They can impersonate the agent completely. They can steal its tasks, or worse, use the agent's permissions to start accessing other systems directly.
but wait, because it gets so much worse. That was just stealing the badge to get into the building.
Yeah.
The second vulnerability, CVE-2026-25593, is about taking over the whole security force. This is command injection.
Yes. If the first bug was stealing the keys to the car, this bug is about hotwiring the car and driving it off a cliff.
This one involves a specific configuration setting called clip path.
All right, clip path. So clip path is a configuration setting in the OpenClaw agent. It's very simple. It just tells the agent where to find the command line interface, the .exe file on the local machine. It's supposed to be a file path, something like C program files OpenClaw bin.
So why would that be a vulnerability? It's just a pointer to a file?
Because the developers, in their wisdom, allowed that configuration setting to be updated dynamically.
Dynamically, as in remotely, over the network.
Yes. The thinking was probably to allow for easy updates or remote debugging. Oh, we've moved the binary to a new folder in our latest update. Let's just push a config change remotely to all agents to tell them where the new one is. It's convenient.
But they didn't sanitize the input.
He did not sanitize the input. I hear that phrase all the time, and it's so important. What it means here is they didn't check to make sure the new value for clip path was actually a file path. So an attacker could overwrite that directive not with a path, but with a command.
Give me an example of the payload. What would an attacker send?
Instead of a file path, the attacker, using their stolen token to authenticate, sends a config update that says, clip path, spawn a new shell and open a reverse connection to IP 192.0.2.1.
A reverse connection. Explain that for the non-hackers in the audience. That's a classic move.
It's a classic for a reason. Normally you have a firewall that stops bad guys from connecting into your network from the outside, but most firewalls are configured to allow traffic to go out. A reverse shell is when the compromised computer on the inside calls the hacker on the outside and says, hey, I'm here, I'm ready for my instructions, tell me what to do.
It brilliantly bypasses the firewall because the call is coming from inside the house.
Exactly. The firewall sees an outbound connection and says, yep, that's allowed.
So let's combine these two attacks. Step 1. I use the WebSocket flaw to get an agent to connect to my fake server and hand over its token. Step 2. I use that stolen token to connect to the real gateway as the agent. Step 3. I push a malicious config update that changes clip path to a command that gives me a reverse shell.
And because the agent is running with those highly elevated privileges we talked about, admin rights in the box, access to network shares, database credentials, it executes that command. It doesn't question it, it's just following a config update instruction.
This brings up the single biggest question for me in this whole mess. We talk so much about AI reasoning. We talk about how smart these models are, how they can pass the bar exam. Why didn't the AI realize it was being tricked? Why didn't the LLM look at that command and say, wait a minute, spawn shell is not a valid file path. This looks suspicious.
That is the most crucial and frankly the most terrifying distinction to understand about this entire breach. This is not a prompt engineering attack.
It's not.
Not at all. We are not trying to trick the large language model into saying something bad or revealing a secret. This attack completely bypasses the cognitive reasoning layer of the AI. It strikes directly at the infrastructure layer, the plumbing.
So the brain of the AI never even saw the malicious request.
The brain was effectively asleep in the passenger seat of the car. The spine, the underlying OpenClaw code that handles networking and configuration, received the electrical signal and just reacted. It's a pure reflex. The code says, if I receive a validated config update, apply it. The attacker provided what looked like a validated config update, so the infrastructure obeyed.
That is chilling. It means you can have the smartest, most ethical, most perfectly aligned AI model in the world.
And it doesn't matter one bit if the software wrapper that gives it hands is vulnerable. The attacker hotwired the car's ignition system while the brilliant driver was still looking at the map.
Total system compromise.
That's the definition of it, and it allows for this concept we're calling agent hijacking. The attacker doesn't just crash the service or steal some data, they become the agent. They inherit its trust, they inherit its access. They are now inside your network, wearing the uniform of your most trusted automated employee.
Let's move into section 3, the fallout. Because when this news broke, the panic was immediate and it was real. I want to compare this to a moment in history. We all remember Log4Shell back in the early 2020s. That was the last time I remember seeing this level of universal industry-wide panic. How does OpenClaw compare?
There are some very strong similarities, which is why the comparison is so apt. Log4Shell was ubiquitous. The logging library was in everything from web servers to Minecraft. OpenClaw is similarly ubiquitous in the agentic AI world.
Okay, so ubiquity is one.
And both were effectively one-click RCE remote code execution. They were incredibly easy to exploit and incredibly difficult to detect.
But there's a fundamental difference in what gets compromised, right? That feels like the key here.
It is a massive, massive difference. Log4Shell gave you code execution on a server. That's very, very bad. You compromise the box. But OpenClaw, because of its nature, allows for agent hijacking. You aren't just compromising a static box, you are compromising an operational entity.
An entity that's designed to move.
Correct. An agent is designed to move laterally across the network. It is designed to log into other servers as part of its job. It is designed to query the production database. If you hack a web server with Log4Shell, you're stuck on that web server until you find another way to jump to the next machine.
Right.
If you hack an OpenClaw agent, the agent is the jump. It comes with the keys for lateral movement pre-packaged.
It prepackaged lateral movement as a service for the attacker.
Exactly. And this leads directly into why this attack was so invisible. It's a textbook case of an attacker living off the land.
Living off the land. I've heard that term used by security researchers a lot. Unpack it in this context.
It means using the legitimate tools that are already present in the target environment to conduct your attack, rather than bringing in your own obvious malicious software.
So instead of trying to download a known virus, which security tools would probably catch,
you just use the admin.exe, or in this case, the openclaw.exe that's already there and trusted by everyone. The agent is the attacker's tool.
So let's put ourselves in the shoes of a SOC analyst, a Security Operations Center analyst. I'm sitting there, it's 3 a.m., I'm watching the screens. Why don't I see this attack happening?
Because to you, and to all of your expensive security tools, it looks like a normal Tuesday. Let's start with user awareness training. Useless here. No human clicked on a phishing link. This happened entirely machine to machine in the background.
Okay, so the human factor is out. What about my EDR tools, my endpoint detection and response software?
Your EDR is looking for anomalies, but if the OpenClaw.exe binary executes a command to update a server, well, that's what it does every day at 2 p.m. It's not an anomaly, it's its job.
The EDR just logs it and says, oh, it's just a trusted agent doing its job. Carry on.
Precisely. The attacker is using the agent's legitimate signed binary to execute their commands. It weaponizes the trusted identity of the AI against the very network it's supposed to be protecting. To your security tools, it looks like routine maintenance. It is the perfect camouflage.
And that reality is what explains the immediate market impact. When this news broke, the major cloud providers didn't just issue a warning. They pulled the plug.
They had no choice. We saw AWS, Azure, Google Cloud, all the big players had to immediately pause their managed OpenClaw services.
I can't even imagine the chaos inside companies at that moment. You're a company that has built your entire modern workflow on these agents. Suddenly, on a Wednesday morning, nothing works.
It was global disruption. Automated code deployments ground to a halt. Financial reconciliation bots stopped processing. Supply chain logistics managed by agents just froze. A complete standstill for thousands of businesses.
It really throws a harsh spotlight on what I would call a governance gap. It feels like as an industry, we sprinted headfirst into this era of agentic AI without ever stopping to check if the foundation was made of concrete or just sand.
We absolutely did. It's the classic tech hype cycle. Innovation always outpaces security. Organizations saw the immediate tangible productivity gains. Look, this agent can do the work of 3 senior admins for pennies on the dollar, and they rush to deploy.
It's FOMO, fear of missing out.
It's FOMO-driven development. And because of that rush, they bypassed traditional, rigorous application security vetting. They treated these incredibly powerful software agents like they were just another productivity app, like a calendar plugin. They didn't fully grasp that they were installing a potential backdoor with root access to their most critical systems.
So we have established that the house is on fire. The automated butlers are now double agents. The perimeter is made of glass. But we have to rebuild. Let's talk about Section 4. The fix and the future.
The good news is the immediate bleeding has been stopped. The OpenClaw maintainers, to their immense credit, were incredibly fast to respond.
They released patches.
Very quickly, version 2026.1.29 was released, which fixes the token exfiltration vulnerability, and version 2026.1.20 fixes the command injection. If you are listening to this and you haven't patched, you need to stop listening and go do that right now.
What did they actually change in the code? Was it just plugging the hole, or did they fundamentally change the logic?
It was a bit of both, which is encouraging. First, for the token issue, they implemented strict origin validation for all WebSocket connections. No exceptions.
So now they finally check the caller ID.
They check the caller ID, they check the origin header. If you are not calling from a pre-approved trusted domain, the door stays shut, period.
And for the command injection flaw.
This was a big philosophical change. They introduced what they're calling safe mode, and it's now the default setting.
Safe mode.
It severely restricts the agent from executing shell commands that originate from dynamic configurations. It basically establishes a new rule. I will only run commands that were hard-coded into my original signed setup file. If you try to send me a new executable command over the wire as a config update, I will ignore it.
That seems like just common sense. Why on earth was that not the default from day one?
Because it reduces flexibility. And developers culturally hate anything that reduces flexibility. The original design prioritized convenience and remote manageability over security. Now security is forcing their hand.
But you've been arguing, and I think the entire security industry agrees, that these patches aren't enough. They're a necessary Band-Aid. But we need a paradigm shift. We keep hearing this phrase everywhere now. Zero trust AI.
We have to move there. There's no other way forward. Patches fix the specific bugs we know about today. They don't fix the flawed philosophy that created them in the first place.
Okay, zero trust has been a buzzword for years. It's on every banner at every security conference. But let's apply it specifically to AI agents. What does zero trust for an agent actually look like in practice?
In practice, it means the complete end of the idea that connection implies trust. We no longer assume that just because an agent is running inside our firewall or just because a command came from the gateway, that we can trust it.
So every single interaction, every API call, every config change is treated as potentially hostile until it is proven otherwise.
Every single one.
Yeah.
Exactly. The future requirement, and I predict this will become a regulatory mandate, will be cryptographic verification for every network connection and every configuration change.
Cryptographic verification. Break that down. What does that mean for the agent's workflow?
Think of it like a digital notary public.
Yeah.
Every time the gateway wants to send a command like spin up a new server, it doesn't just send the text. It mathematically signs that command with a private cryptographic key that only it possesses.
Okay.
The agent receives the command and it has the gateway's public key. It uses that public key to verify the signature. It proves with mathematical certainty that the command came from the real gateway and that it has not been altered in transit.
So even if an attacker has hijacked the connection, they can't forge a valid command because they don't have the gateway's secret private key.
Precisely. If the signature doesn't match, the agent just drops a command on the floor. It doesn't execute it. The trust is in the math, not the network connection.
That sounds incredibly secure. It also sounds computationally heavy. Won't that slow everything down? Having to do a crypto handshake for every single packet, every command.
It will add latency, yes. There's no free lunch. We are trading milliseconds of performance for security and resilience. But when the alternative is losing complete control of your entire production infrastructure, that is a trade-off I think every CISO is now willing to make.
Yeah, and the regulators are going to force them to make it, aren't they? This feels like it's going to have major legal ramifications.
100%. The EU AI Act is already being re-examined for amendments to cover agentic systems. U.S. cybersecurity regulations from CISA are going to pivot hard to this. We are going to see a baseline requirement that says, if you deploy autonomous agents in your critical infrastructure, you must be able to prove they are secure by design using a zero-trust model.
You also mentioned a necessary architectural evolution. Something about decoupling. This sounded fascinating to me. Decoupling the connector from the executor.
This is where I think the real long-term innovation will happen in the next generation of these frameworks. Right now, the OpenClaw agent is a monolith. It's one big block of code that does both the talking to the outside world and the doing of commands on the inside.
Right. It downloads the command and it runs the command, all in one process.
The frameworks of the future need to physically separate those functions. Imagine what some are calling air-gapped logic chains.
Air-gapped logic chains. Okay, I'm listening. That sounds promising.
You would have one tiny, simple component, let's call it the connector, whose only responsibility is talking to the internet. It is heavily sandboxed. It has zero permissions to do anything on the local machine. Its only job is to receive messages and pass them inward.
Okay, so if the connector gets hacked, the attacker is trapped inside a tiny, useless box with no power.
Exactly. The connector then passes the message to a completely separate, highly privileged process, the executor. But here's the absolute key. The executor does not and cannot talk to the internet. It only listens to the connector. And its job is to objectively evaluate the request before doing anything.
So instead of the old model where the connector says, hey, run this command, and the executor just says, okay, the new model is the connector says, I received a request to run this command. And the executor says, hold on, let me inspect that request first. Does this command match our security policy? Is the cryptographic signature valid? Does it make sense in the current context?
Precisely. It's building a system of internal checks and balances directly into the agent's architecture. It prevents one compromised component from being able to bring down the entire system. It's defense in depth at the micro level.
This whole shift feels like we are finally professionalizing the technology. We are moving from the Wild West of just hooking LLMs up to the internet to something that looks more like modern banking software.
We are. And that, of course, creates a brand new market. Get ready to hear a new acronym, AISPM.
AISPM, AI Security Posture Management. That is a mouthful.
It is, but you're going to see it on every vendor website by the end of the year. It's going to be a booming market.
So what does an AISPM tool actually do? Is it a new kind of firewall? Is it a scanner?
Imagine a map of your entire corporate network, but instead of just showing servers and routers, it shows agents and their intent. It shows you in real time. Agent A has permission to access database B. Agent A is currently communicating with Gateway C. Agent A has not used its root privileges in 90 days.
So it visualizes the invisible workforce that we've deployed.
It visualizes them, and it spots vulnerabilities in their configuration. It maps their data pathways. It automatically flags overprivileged agents. It will be the tool that asks the question, hey, can someone explain to me why this calendar scheduling bot has root access to the payroll server?
That seems unnecessary.
Exactly. Before this breach, nobody was checking that. Now, AISPM tools will automate that process of checking and enforcing least privilege for AI. It's all about visibility. You can't secure what you can't see.
It really feels like a deep cultural reset is needed, too. Beyond the tools, we've been living in the move fast and break things era for so long. Those are the famous Facebook motto, right?
Yeah. That philosophy works fine for social media apps. If you break a like button, it's annoying, but nobody dies. That philosophy does not work when you are building autonomous agents with root access to your critical production servers.
When breaking things means remote code execution and total system compromise.
You can no longer afford to move fast and break things. The philosophy must change to secure by design. Your developers have to be trained to treat every single input, every line of text from a user, every URL in a log file, every config file, as potentially hostile until proven otherwise.
Paranoia as a professional virtue.
It has to be. Professional paranoia. No more assuming that because a piece of data came from the internal network, it must be friendly.
So let's try and bring this all home. What does this all mean for the listener, for the industry? We've gone on this journey from the incredible high of agents will do everything for us in early February to the catastrophic low of our agents are vulnerable spies mid-month. And now we're looking at the long road to rebuilding.
We're maturing. It's as simple as that. This is the necessary, albeit painful, growing pain of a powerful new technology. For 2 years, we treated AI like it was magic. Now we have to start treating it like what it is. Software.
And software has bugs.
Software has bugs. But software can be engineered securely. We know how to do this. We just have to apply the discipline.
Let's wrap this up with our final thoughts. We've covered the journey from boundless optimism to a very harsh reality check.
It's a classic story, really, of innovation outpacing security. But if there is one core lesson to take away from the OpenClaw breach, it is this. Intelligence does not imply invulnerability. Just because the AI brain is smart, it does not mean the code that it runs on is secure.
We have endowed software with the ability to act. We gave it hands.
And we can no longer afford to treat those agents like trusted employees. We have to treat them as what they are, incredibly high-value assets. They're powerful, they're capable, but they require constant, rigorous protection and monitoring.
The era of blind trust and autonomy is over.
The era of zero-trust AI has begun.
I want to leave our listener with one final provocative thought to chew on. We talked a lot today about securing the code, the plumbing. We talked about securing the network, the pipes. That's all infrastructure. But if these agents are going to be negotiating contracts, managing financial portfolios, and running critical infrastructure, at what point do we need to start thinking about how to secure the intent?
That is the multi-trillion-dollar question, isn't it?
If an agent is technically secure, no bugs, perfect crypto, but its core goal function is manipulated by an adversary. If an agent running a power grid decides that the most efficient way to maximize profit is to shut down the safety systems, that is a whole other class of problem, maybe a deep dive for another day.
That is the next frontier.
Yeah.
And it is going to be even harder to solve than this was.
On that cheery note, thank you for listening to this deep dive into the OpenClaw breach. Stay curious, stay skeptical, and please, for the love of God, check your origin headers. We'll see you next time.